3, 1, 2, 3. Good afternoon, everyone watching. We're currently in North County. Kilo Foxtrot 45 in Florida. Mags or both. Couple of primes, fuel selectors on the left tank. Let's crank up that baby. Clear! It's nice to get that engine started on the first shot. Okay, engine's up and running. We got the oil pressure building up. Oil temperature is still pretty breezy. And it is breezy, so we're going to close the window here. Alright, GPS is up and running. We got 12.2 volts. That's kind of low. Let it get up there. TCAS is up and running. Battery's normal. Looks like we need to press up for flight. Alright, we'll put it on flight mode. And it is on flight mode, and we're going to get some weather. North County Automatic Weather Observation System, 119.975. There we go.
Celsius, altimeter 3008. North Palm Beach County General Aviation Airport, automated weather observation 1814 Zulu weather, wind 180 at 6, visibility 5, light rain, sky condition, ceiling 3,100 broken, 4,300 broken, temperature 24 Celsius, 2.22 Celsius, altimeter 3008.
180 at 6 is the wind. For taxi, seatbelts on. Brakes release. Harnesses are on. Let's get that bird moving. at 6. We got runway 8, which will give us 100 degrees off. We got runway 26, which will give us 80 degrees off.
North Palm County, 444 runway taking off, 8 right, North Palm County.
Which will give us 50 degrees off. I would say runway 13. North County traffic, North County traffic, Luscombe traffic, taxi out of the ramp, runway 13 for departure. Take it straight out to the southeast, North County traffic.
North Palm County, 444 row 8 right, your left departure, North Palm County.
Pretty marginal weather today, as you can see. Broken clouds, light rain. Clear left. Clear on the right. Mission today is basically going home sweet home for about 4 days off. Plan for tomorrow. Hopefully some breakfast in Orlando.
North Palm County, 444 reporting the pattern.
Then hang out with the northwest. And mechanics and the airport. Check out on the inspection in progress, and then head back home. There's your windsock. Looks about 30 degrees off, maybe about 40 degrees off the nose. North County traffic, Luscombe traffic, holding short runway 13 intersection Delta for takeoff straight out to the southeast. We'll be airborne in about 2 minutes. North County traffic.
North County, 07.
Okay, let's run up that big boy. 1500. 2 clicks left. Check for drop back.
1 click left. Roger, thanks. There was a note on that it was closed.
Carburetor heat on.
So, the Nova
check for drop. You're good.
Yeah, Roger, I think it's closed men on the weekdays. They're doing their extension work when they're working the present.
Lights coming on. There's your drop. Alternator's charging. Doors and windows unclosed. Harness is on. Everything's looking good. Back to idle. I would say that power plant is up and running, tip-top shape. Flight controls check. Left aileron, stick left. Left aileron goes up. Right aileron goes up. Stick to the right. Elevator up and down. Full motion and rudder. Flight controls are checked for departure. Finals clear. North County traffic, Luscombe traffic, taking off runway 13 straight out to the southeast, Luscombe in North County taking off. Okay, there we go. Final is clear indeed. Wind is from the right.
Okay, so
double check the wind sock. And wind is from the right. Alright. Nice and comfy, center line, directional control, slowly get that power up, full throttle within 5 seconds. There we go, right rudder.
Here, 7, 6,
Hold that pitch attitude. Right crosswind, aileron stick right, right up to the right, right into the wind. Right there. Positive rate of climb, landing gear is coming up. Just kidding. Next gear here. Alright, looks like pretty low visibility. But we can still see where we're going. North County traffic, Luscombe traffic. Left turn to the northeast, North County traffic. Oh boy. Left rudder. Nothing better than sticking rudder, let me tell you. Clear left. Traffic 2 miles, same altitude, keep an eye. Trim for about 80 miles an hour climb. Looks like clouds out there. We're still in Class Golf airspace at this time, which means 1 mile visibility, clear of clouds will keep us out of trouble. Clear on the left. North County traffic, Luscombe traffic, left turn to the north, about 800 feet climbing northbound, 3 miles north of the airport. North County traffic. Traffic's clear. Right on course. Okay. Transponder check. 1200. Traffic return altitude 1100. 1100 looking good. Okay, at this time, we're entering Class Echo airspace.
Thank you.
Yeah, welcome. Okay, direct up to yourself, copying 1331 on the ground, 2 kilo, back to the
And departing North County. We can get rid of that Unicom. And basically look outside for traffic. How do we scan for traffic? We're looking out in sectors, 10 to 20 degree sector, and focus for about 3 to 4 seconds. And then keep moving your eyes. Doesn't hurt on the climb, some shallow turns. As you're turning left and turning right, you actually see traffic below you, and at the same time, if you have sunroof or sun window like this guy, you can actually look above. Back to Class Echo. Class E as an Echo will require you to have minimum 3 statute mile visibility and 500 feet below clouds, 1,000 feet above clouds, and 2,000 horizontal distance from clouds in order to maintain your VFR. Minimums. 1,900, we get up to about 2,500 feet. We may get up a little higher when we get a little further north, but at this time we'll stay at 2,500 to remain 500 feet below the clouds, which are 3,000 feet. Climb checklist, power set, extra set, oil pressure is good, oil temperature is good, RPM's on the green, climb checklist is complete. Looks like it's clearing up further up to the north, so we're running away from that rain cloud, which is a good thing. As we're climbing up, we can talk a little bit about constant airspeed climb. Every aircraft, generally every aircraft, has best rate of climb and best angle of climb. Okay, coming up to my cruise, I'm going to throttle back to about 2,300 RPM, which is relatively where you want it for best efficiency, which is LD max. And we'll talk about that when we get a little further up north. Cruise power is set, 2,200 RPM, altitude is set, 2,500 RPM, excuse me, 2,500 feet. Oil temperature is good, oil pressure is good, everything looks to be normal. And we keep on looking outside and scanning outside for traffic because we have to maintain VFR. Back to rate of climb and constant airspeed climb. We can climb on this aircraft at 2 different climb speeds, generally. Best rate and best angle. When you're looking at best rate, which is about 72 miles an hour for this aircraft, it will give you the best rate. As you can hear, best rate of climb, best rate. To simplify it, it will get you up to altitude the fastest, which means if you're trying to get up to 3,500 feet for your VFR cruise, you use your best rate, you will get to 3,500 the fastest. It will give you the best rate of climb up there. Generally, we want to climb at best rate because as you're climbing up, you get to your altitude faster. The faster you get to your altitude, the better your true airspeed because the air is less dense. However, there's certain restrictions as far as best rate. Sometimes you need to climb at the best angle. And the best angle of climb, as we can hear, is the best angle. The best angle of climb is the airspeed that the aircraft will climb to get the best angle over obstacles, to get off the runway, to climb above a hill, to clear any antennas, or any obstacle departure procedures. On this runway it wasn't a factor, but let me tell you, if you're climbing off 1,000-foot strip with a 50-foot obstacle on a departure end, you betcha you want that best angle climb airspeed. You don't want that best rate, because that best rate may be the difference between life and death. If you don't get that best angle, you're not going to be able to clear that obstacle, especially if it's really, really tight. At this aircraft, if it is a short strip, you want to have a short field takeoff and climb technique, which means you're going to apply full throttle, get your maxed RPM before releasing your brakes, and keep that back pressure on the stick to just get off the ground as quickly as possible to get into that ground effect and get your climb speed where you want it to clear the obstacle. Okay, so far it's okay. We know what's the best rate, and we know what's the best angle. So to summarize, constant airspeed climb, we have best rate, get up to altitude as quickly as possible with a minimum amount of time. And we have best angle, which is clear any obstacles on the departure path and get you the best angle of climb. Generally, the steeper the angle of climb, the better it is, and that's why you want to use best angle. Back to LD max. We were talking about cruise speed. At about 2,200 RPM on this aircraft, with this particular weight today, with generally standard atmosphere, you want the LD max. Why do you want the LD max? LD max is the lift to drag ratio, which is the best for best economy, best efficiency, minimum drag, maximum lift. So you're getting all four things at one shot when you're getting LD max, okay? For example, let's go ahead and demonstrate what's getting outside that tip of that LD max. LD max is the tip where you get the most efficiency. Let's go ahead and throttle back to about 1,900 RPM. You can hear the engine revving down, slowing down the RPM. The nose wants to drop as we're throttling back. As we're throttling back, the nose wants to drop. We're going to apply back pressure on the stick to get that nose back up. At the same time, we're going to apply back pressure trim to get that control force on the stick from getting that nose down. Okay, look what's happening here. We're traveling very, very slow. We're doing about 60 miles an hour, which is slow flight. At that point, the aircraft pitch is increased by about 2 to 3 degrees. As the aircraft pitch is increasing, at the same time, your parasite drag and your induced drag is increased. And why is that? Parasite drag is the airframe moving through the air. As we're cruising at higher pitch, there's more airframe exposed to the relative wind. As there's more airspace, there's more airplane exposed to the relative wind, you have more parasite drag. At the same time, induced drag, which is drag that's created by lift, is also increased. Which means we're traveling along here at relatively high drag. Are we getting as much lift? Not necessarily. Because as we're creating more induced drag, the relationship between the drag and lift changes, and then we have less lift at the same time, and we're traveling much slower. As we're traveling much slower, we have less efficiency out of the airplane. Less efficiency, less miles per gallon. More fuel trip, more fuel burn for the same trip, and that's when you're not considering the wind, okay? Let's go ahead and shove that throttle all the way in there. As we're getting the throttle all the way in there, the airspeed is building up. Altimeter is at the same altitude. I'm relieving the control pressure with nose down trim because the aircraft wants to come up. And at the same time, I'm going to be burning more fuel as I'm going faster. I'm right at the red line, which is 2,600 RPM, 2625 for this aircraft. Now for this particular airframe with this power plant, I'm below my LD max, and I'll explain why. As I'm traveling faster through the air, my parasite drag is increased. My induced drag is generally decreased. And lift is decreased. However, in order to go that fast, look how much power I got into the engine. I'm burning so much more fuel that at this particular power setting, the aircraft is not going to be as efficient as LD max, which is back to about 2,200 RPM, which is what I'm going to do right now. Right back to 2,200. So far, so good. So to summarize, in any aircraft, when you're at LD max, you're at the best efficiency with a minimum drag and maximum lift. And that's where you want to be at for best efficiency. Over here in Palm Beach, fuel cost is about $7 a gallon. Some other parts of Florida, you're looking at about $5. So if you're into fuel burn and save gas for the same trip, you want that LD max. And you want to find that LD max in any aircraft you fly to get the best efficiency. And that's to save gas and to get the maximum miles per gallon. Just like a car. When you're driving a car, you want to get the maximum miles per gallon. Okay. Looks like we're just abeam Stewart International, which is right up there to the right, about 10 miles east of us. Next airport is going to be Fort Pierce, which is further up. Traffic 3 miles, 1,500 feet below us. Just keep an eye on the TCAS and try to visually find that traffic by looking outside the windows, which is basically the pilot's responsibility when you're flying VFR. See and avoid. Looks like that traffic is not a factor because it's about 4 miles out now, so actually flying away from us. Okay, we're going to terminate this and get back to the second lesson, which is the approach and landing into Vero Beach.